Hey guys, Mr. Schaefer here. I've created a little instructional video for you guys while I am away. And this video is going to be on the Bohr model of the atom. Before we discuss this Bohr model of the atom, I would like to first talk a little bit about the Rutherford model of the atom. So, the Rutherford model, as we've talked about before, has the proton in the center, or protons in the center of the nucleus, followed by, or surrounded by electrons, which were thought of as particles. Now, as we discussed previously, the electrons in orbit around the nucleus, if they were just particle in nature, should eventually just fall into the nucleus. However, as we've talked about, this has never been observed. So, what actually is happening? When you acknowledge the wave nature that electrons also have, and when you study the spectra, as you have in your labs, we come to the conclusion that electrons are not, quote, allowed to be any location surrounding the nucleus, but instead that electrons can only exist in certain defined energy levels. And here's where we come to the Bohr model of the atom. Now, Niels Bohr, a famous physicist/chemist, described the hydrogen atom as having energy levels. Now, the protons, still in the nucleus, but instead of electrons being located anywhere around the nucleus, instead they're found in what are called distinct energy levels or orbits. These distinct energy levels have maximum numbers of electrons. We learned previously that N is the symbol for the energy level, and N is equal to 1 refers to the lowest energy level that an electron can be in. This first energy level maximizes with 2 electrons. The second energy level can hold a total of 1, 2, 3, 4, 5, 6, 7, and 8 electrons. The third energy level can hold a total of 18. I'm not going to draw in all of those, but 18 electrons. Let's summarize in a chart. Energy level and max number of electrons. On the first energy level, 2 electrons maximum can exist. On the second energy level, that's right, 8 electrons. On the third energy level, 18 electrons. And the fourth energy level, 32 electrons. There are higher energy levels, but that's all we're going to discuss for now. So what does this mean? When you look at the periodic table, you find an element such as lithium with the number 3, along with a weight underneath it. Recall that the whole number 3 refers to the atomic number, also known as the number of protons. So for lithium, oops, gotta erase that. So for lithium, we have 3 protons in the nucleus, and we have 2 electrons in the first energy level, and we have 1 in the second energy level. Why is that? In all of the cases that we're going to talk about today, the number of protons is going to match the number of electrons because these are neutral elemental substances or atoms. With 3 protons, we must have 3 electrons. Let's do another example. Let's take magnesium. Finding magnesium on the periodic table, it has an atomic number of 12. So, with 12 protons in the nucleus, we have 12 electrons that we have to add to this atom. 2 electrons maximum fit in the first energy level. 8 electrons fit in the second energy level. And now that we've maxed that out, how many plus 10 equals 12? That's right. 2 more electrons give us 12 electrons to match the number of protons. So magnesium has 2 electrons in what is known as the valence energy level or valence shell. The valence refers to the highest energy or the outermost energy level. Let's do one more. And look at calcium. Calcium is element 20. Element 20. All 18 columns. In the periodic table that I'm going to give you in a moment, the middle of the periodic table, the part that I am now crossing out, is blanked out. And that's because these transition elements, everything from group 3 through group 12, this whole middle section is omitted. The reason why is because it complicates our understanding of atomic structure and the Bohr model in particular. We'll be adding back information on these elements in the next week. But let's look quickly at element number 31, gallium. Now, element number 31 is the element that I'm going to need you to remember for this particular activity. Elements only expand to 18 electrons in the third energy level beyond gallium in our example periodic table that you'll receive shortly. So, what I mean by this is, so let's look at Ca calcium. 20 protons, 2 electrons, 8 electrons. But because 20 is below element 31, we are going to not use the 18 electron rule yet. And we're only going to fill our third energy level with 8. So 18 is only possible in our periodic table after element 31, gallium. Before then, we max out our third energy level at 8 electrons. So 8 plus 2 is 10, plus 8 is 18, and we need, that's right, 2 more electrons. So calcium has 2 electrons in its valence shell. That concludes our instruction for now. Our substitute, Mr. Carter, is now going to give you a periodic table that I want you to draw all over, and I want you to make Bohr models of each and every element that's shown on that periodic table. The reason I'm asking you to do this is because ultimately, if you do it correctly, patterns will emerge. I'd like you to look and determine what kinds of patterns emerge down groups or columns, as well as any patterns that might emerge across rows or periods. Flipping that periodic table over, you'll notice a series of questions that are on the back. So, for the rest of this time today, I would like you to, number 1, complete the periodic table, front and back. And for homework, I would like you to complete your lab from last week. That means the calculations and the questions. And I will see you all on Wednesday when I get back. Good luck. Bromine. We have 35 protons, 2 electrons, 8 electrons, and because we are past element 31, gallium, we can expand to 18 electrons into our third energy level. Do we need 18? 18 plus 8 would be, or 18 plus 10 would be 28. So we now can hold 18 plus 2 is 20, 28 electrons, and we need how many more? That's right, 7 more. So once you've reached element 31, you can use 18 electrons to max out that third energy level. Let's go back and take another look at that periodic table. Let's take a look at one more element. Let's look at calcium. Now, calcium has 20 protons and 20 electrons if it's neutral. That's 2 in the first energy level, 8 in the second. And then we have to ask ourselves that question, is calcium before or after gallium? And because gallium is element 31 and calcium is element 20, it is before gallium, so we do not max out that third energy level at 18. So only once we've reached gallium. So we max it out at 8. Remember, the rule is 2, 8, 8 until you get to 8 element gallium, and beyond gallium, we can go to 18. So that leaves us with 18 electrons at the moment, 2 more for 20. Let's wrap up. Elements after, or 31 and beyond, can expand that third energy level beyond the 8 into 18. Only after gallium, though, is that possible. So for the rest of the time today, I would like you guys to work on number 1, complete the periodic table that Mr. Carter is going to give you, filling in the Bohr model of every single electron for which the atomic number is given. 2, answer any questions on the back, in particular focusing on those that ask you to identify patterns, both across a period and down a group. And 3, put in your notebook that your homework tonight is to finish the lab, calculations, and questions. That's all for now. See you guys on Wednesday.